Can afford a Ferrari, but that don't mean I can get you there. I guess he's an Xbox and I'm more Atari. But the way you play your game ain't fair. I picture a fool that falls in love with you. Oops, she's a gold digger. Well, just don't you know? Ooh, I got some news for you. Yeah, go to run tell your little boyfriend. I see you driving round town with the girl I love, and I'm like, forget you. I guess the change in my pocket wasn't enough. I'm like, forget you and forget her too. Said if I was richer, I'd still be richer. No, ain't that something? And although that's pain in my chest, I still wish you the best. Forget you. Now I know.
In our model, we have 5 11.1 volt 3-cell lithium polymer batteries that are connected in series. They are connected in series so as to ensure that we can get maximum voltage out of them. Why do we need maximum voltage? This is because the amount of charge in the capacitors is equivalent to capacitance times voltage. Thus, if we want maximum charge, we need to have maximum voltage. In our model, we also have a diode to prevent the backflow of current from the capacitors to our battery. Before the start of our experiment, we also ensured that we had fully charged our batteries and that they were balanced.
On top of batteries, we also have 5 capacitors in our model. Once the switch is closed, current will flow from the batteries through the wires to reach the 5 capacitors, and the capacitors will store the charge. Once the capacitors have been charged, the switch will be opened and we will close the switch such that the current will flow from the capacitors to the coils, and so the projectile will be shot out of the barrel. The reason why we're using capacitors instead of just connecting our battery straight to the circuit is because firstly, so that the circuit does not become a short circuit, and secondly, we need a short pulse of current. Our model would not work if we have a long pulse of current.
So in this diagram, the current is flowing upwards, and so with reference to the right hand grip rule, the current is in the direction of my thumb, so the magnetic field generator will be in the direction of my fingers, which is in this direction. Now with reference to the second diagram, the current is flowing around the loop in this direction, so it's with reference to the right hand grip rule is something like this. And so the magnetic field inside the loop will be upwards and the magnetic field outside will be pointing downwards. And now the third diagram, the current is flowing in the anti-clockwise direction around the loop. So with reference to the right hand grip rule again, the current will be in this direction and the magnetic field will be pointing in the direction out of the board in the center of the loop. Outside the loop, it will be going into the board. Also in addition, more coils will generate a stronger magnetic field. Also, more current will generate a stronger magnetic field as well.
In our model, we've set up a magnetic field using a coil of copper wires. But how does that magnetic field propel our projectile, since it has no inherent magnetic charge? The reason our projectile is propelled is because when our projectile is put inside our barrel, the magnetic field induces 2 poles in our projectile. The field lines predict the direction which a north pole would tend to move. As such, a north pole will be formed in this part of our projectile, while a south pole will be formed in this part. But how does this cause our projectile to be propelled? Because if it was right in the middle, North Pole would want to move in this direction, but the South Pole would want to move in that direction, so there will be no net force. However, when we load our projectile into our barrel, we have it at around position 2, such that the front of it is in position 3 and the back is in position 1. As such, the North Pole formed at position 3 wants to move forward, while the back pole at the position 1 wants to move backwards. However, as you can see, the magnetic force is much stronger at position 3 than at position 1. As such, there's a net force in the north direction and our projectile is fired.